Hi, this is Jennifer, Assistant Professor, Department of Chemistry. Today's my topic green chemistry. Green chemistry consists of chemicals and chemical processes designed to reduce or eliminate negative environmental impacts. The use and productions of these chemicals may involve reduced waste products, non-toxic components, and improved efficiency. Green chemistry is a highly effective approach to pollution in prevention because it innovative scientific solution to real world environmental situations. Next, definition defined as the invention, design, and applications of chemical products and processes to reduce or to eliminate the use and generations of hazardous substance. Next, what is chemistry? What is green chemistry? Green chemistry is the science of designing safer products and processes for a more sustainable future. Proactive, innovative science which targets pollution prevention at the source, stopping or reducing waste before it even begins. Next, green chemistry is about reducing its waste, materials, hazard, risk, energy, cost. Next, why green chemistry? Term coined by Dr. Paul Anastas known as the father of green chemistry. He defined it as the utilization of a set of principles that reduces or eliminates the use or generations of hazardous substances in the design, manufacture and applications of chemical products. Next, principles of green chemistry. Prevention of waste or byproducts, atom economy, less hazardous chemical synthesis, designing safer chemicals, use safer solvents or reaction conditions, increase energy efficiency, use of renewable feedstocks, reduce chemical derivatives, use catalysts, design for degradation, real-time analysis for pollution prevention, inherently safer chemistry for accident prevention. Next, prevention of waste or byproducts, design processes which minimize waste. Better to prevent waste than to clean and treat it. Atom economy. Atom economy is equal to mass of atoms in desired product 800 divided by mass of atoms in reactant. Concept developed by Barry Frost evaluates the efficiency of a chemical. Choose transformations that incorporate most of the starting materials into the product, increases the efficiency and minimize waste. Claisen rearrangements, Witting reactions, less hazardous chemical synthesis. Wherever practicable, synthetic methodologies should be designed to use and generate substance that possesses little or no toxicity to human health and environment. Next, polycarbonate synthesis. Phosgenes process. Disadvantages. Phosgenes is highly toxic corrosive. Requires large amount of CH2C12. Polycarbonate contaminated with Cl impurities. Polycarbonate synthesis. Solid state process. Advantages. Diphenyl carbonate synthesis without phosgene eliminates use of CH2C12. Higher quality polycarbonates. Next, designing safer chemicals. Chemical products should be designed to preserve efficacy of the functions while reducing toxicity. Anti-fluorinting are generally dispersed in the paint as it is applied to the hull. Organotin compounds have traditionally been used, particularly tributylene oxide. TBTO works by gradually leaching from the hull, killing the fouling organism in the surrounding area. Organotin compounds are chronically toxic to marine life and can enter food chain. They are bioaccumulative. Next, use safer solvents or reaction conditions. The use of auxiliary substance solvents, separations, agents, etc. should be made unnecessary whenever possible and when used occurs. Solvent substitutions. Water as a solvent. New solvents is a ionic liquids, supercritical fluids. Next, increase energy efficiency. Energy requirement should be recognized for their environmental and economic impacts and should be minimized. Synthetic methods should be conducted at ambient temperature and pressure. Next, use of renewable feedstocks. A raw materials or feedstock should be renewable rather than depleting whenever technically and economically practical. Next, reduce chemical derivatives. Unnecessary derivation, docking group, productions or deproductions, temperature modifications of physical chemical processes should be avoided whenever possible. Reduces atom economy, increase waste. Use catalytic reagents as selective as possible, as superior to stoichiometric reagents. Readily regenerated, separated, recyclable, mild conditions. Next, design for degradation. Chemical products should be designed so that at the end of their functions they do not persist in the environment and instead break down into innocuous degradation products, CFCs DTT. Biodegradable polymers. Next, real-time analysis for pollution prevention. Analytic methodologies need to be further developed to allow for a real-time in-process monitoring and control prior to the formations of hazardous substances. Real-time analysis for a chemist is the process of checking the progress of chemical reactions as it happens. Knowing when your product is done can save a lot of waste, time and energy. Inherently safer chemistry for accident prevention. Substance in the form of a substance used in a chemical process should be chosen so as to minimize the potential for chemical accident, including release, explosions and fires. Various industrial accidents. Example, Bhopal gas tragedy. Next, the role of green chemistry. Green chemistry is a tool for a sustainable future. Incorporation of sustainable thinking in experimental design. We must educate students about GC in a way that encourages applications of the knowledge. Thank you.